Hello everyone, this is Jill. Welcome to part 2 of the recitation 0T, which is losses. In this part of the recitation, we'll cover visualization and choosing the right loss function, go over some useful loss functions such as cross entropy and CTC loss, and introduce ways to write your own custom losses with some examples. In the previous part of this recitation, we have seen various type of losses and their PyTorch implementations. And in this part of the recitation, we'll see how to choose which is the best amongst them for your use case. So one of the best ways to do this is using visualizations or visualizing these loss functions. For each of these cases, we generally have one target value, which is mostly one, but could be something else. And we'll have a set of probabilities, which could be in one-to-one correspondence with the target or not. So let's take for now an example where they are in one-to-one correspondence. So here we are computing two type of losses, BC loss, which is the binary cross entropy loss, and MSE, which is the mean squared error loss, both of which have a target value of 1. So if you can see over here, we are assuming our predictions to be in the range of 0.1 to 0.99 and our targets to be 1. And we are calculating the losses over here. And we can visualize these losses in this particular way. You can just use the plot functions over here and show it. So since the target over here that we are considering is 1, the further the prediction is from the target, the greater is its loss value. And this is what we want, even for all loss functions. But if we observe over here, the penalty provided by the BCE loss is much higher than by the penalty provided by the MSE loss. And if you would consider L1 loss, it'll be even lesser. So if you have many outliers, it's better to use L1 as these losses will penalize the misclassifications much harder. And we want, in certain cases, that these outliers should be able to predict the class they correspond to. And so we would want the penalty to be lower in that case. Similarly, we can also implement our own custom loss function. One of the examples is hinge loss over here. In this case, we are just writing a simple function for the loss, but we can also create a class for it and implement it in that way. Here, hinge loss is exactly what happens in SVM. So here for target values of 1 or greater, the loss is 0. And for values that are less than 1, we have a linear relationship over here. So similarly, another loss that we cover as an example for custom functions is focal loss. Focal loss is a loss which covers significant penalty for misclassified objects. So this can be very helpful when there is a huge class imbalance. So if there is some class that has lots of samples, the model might predict that class more often, and so it is not right. We might want to penalize harder so that it learns to predict from the other classes also. For this, we might want to give a separate weight to one of the classes, depending on how many samples we have. And this could be tedious, like finding these weight values. So focal loss with its formula over here is able to handle all of this. So if we visualize and compare the focal loss with the binary cross entropy loss over here, we can see that focal loss is penalizing much harder than the binary cross entropy loss when there is a misclassification. And as usual, the loss will decrease as it approaches the target value of 1. But if we see like the penalization of focal loss is much higher than that we see in binary cross entropy loss. And again, even with focal loss, you can alter the values of gamma. The higher the value of gamma, the more will be the penalization. So even this is one of the hyperparameters that you will be able to tune when you use focal loss. So till now, we have seen losses which have one-to-one correspondence. But what do we do in cases where we do not have a direct one-to-one correspondence between the input and its label? In these cases, we can use losses such as CTC loss. So if we take as an example a case of speech to text, you'll be working more on this in homework 3. But speech to text is an example where the input, the number of input labels is not going to be equal to the number of targets. So the length of these input and the target sequences will be different. In these kind of cases, we need to use CTC loss. In this case, the speech will have the input sequence length, which will correspond to the audio frequency, while the text part will actually depend on what is said in the speech. So it's going to be different. So if we see over here in the example, we can take the input sequence length as 50 and the target sequence length as 30, which is different from that. And then we can use CTC loss to sort of compare these um, values and calculate the loss. CTC loss will then consider the repetition in the input or the boundaries that are defined by the blank token and compute the loss for you. So we will be covering more about this in homework 3 part 2, but this is just for defining a use case for this kind of loss. So as a summary, the choice of loss functions directly influence the training speed and the optimization stability against different type of randomness in the training process. And so it also affects the overall test accuracy. Hence, it's very important to select the loss function that works the best in the application at hand. So in PyTorch, there are many losses already implemented, and they are either stateful, which are class based, or stateless, which are functional functions. So you'll find both these kind of implementations within PyTorch also. But there will be cases where you want to use some specialized or niche loss functions that might be significantly useful in your case. Some examples would be CTC loss that we just saw and will be using in homework 3. And there could also be various other contrastive losses such as cosine loss or arc face loss or sphere face loss, center loss, and so on, which would be very helpful in homework 2, part 2, where we will have to learn a better feature representation rather than just classification. So you can use the content that has been covered in this recitation to implement these losses either using PyTorch or writing a custom function for whichever kind of losses that you want. Apart from this, there are a few more references over here, which you can also utilize as and when you require during your homeworks. Here is a survey on the losses that are used in machine learning and the PyTorch implementations that we covered above. You can go through all these implementations over here to see how to use them. And here is some extra literature that you might want to look into if you're interested. Thank you.